Hello everyone. This lecture is about the star delta transformation, but before that there was some topic remaining which I had discussed in the interactive session, but were not added to some PowerPoint slides, so we will discuss those as well. Okay. So these are the contents of our today's lecture. We will see the line to phase voltage and current conversion in three phase, and phase to line voltage and current conversion, and after that we will discuss the total power and phase power respectively, and after that we will go to our discussion on why we transform from star to delta or delta to star, and what's the benefit of it. Okay, besides we will also have some formulas for the conversion of the said things. Okay, so let's dig in. The first thing that I had to discuss with you people were the phase to line voltage and current conversion. So phase to line means that we will be having let's say a star and delta connected sources, and we will convert the current in the phase to the current in the line. So this will be IP and this will be IL. Okay, and after that we will have the same thing for star. Okay, so as the diagram says that whenever there is a source, the currents inside source are always emerging. So emerging currents add up. So we can say that the IL is the combination of two currents which are adding up. So let's say first current is this IP, and the second current is at 120 degree with IP, so the total current would be this one. So this suggests that IL is equal to under root 3 times the IP in in delta connected source. So the current is multiplied by under root 3 when the phase current is converted to the line current. Similarly, if we check this circuit, the emerging current IP is equal to IL. So the current remains the same in phase and line in Y connection. So we are done with these two things. Now if we check the voltage in the same scenario, so what happens to the voltage? Let's say this is our VP. So VP star is this, and this one is VL. So in VL the two voltages are adding up. So this, let's say voltage 1, this one is, let's say, voltage 2. So VP and this is VP, and we add it up to get under root 3 VP. So in Y connected sources, the voltage is multiplied by under root 3 when the phase voltage is converted to line voltage. So this is the phase voltage, this is the line voltage. The VL is equal to under root 3 times VP. Okay, so we are done with this one as well. Whereas if we check the voltage in this delta, so in delta this is our VP as well as VL. So VP is equal to VL in line volt. Okay, so this is when we were converting from phase to line. So let me revise it a bit quicker. So I will delete this thing and this thing. Okay, okay, so let's say this is our delta connected source. This is our IP, this is our IP angle 120 degree. So this will be IP plus IP angle 120 degree. So that would be equal to IL is equal to IP into under root 3. Okay, whereas here it is VP and here it is VL, so VP is equal to VL. Similarly, if we have something uh, like this, so this is our VP and this is our VL, so VL is equal to under root 3 times VP, whereas IP is equal to IL, so IP is equal to IL. So these are the 4 conditions which we discussed in this slide. Okay, now coming toward the other section, when we are converting a line voltage or current to a phase voltage or current. So line to current, line to phase voltage and current conversion. So same thing, if we are having, let's say, this source, 3-phase source, and we are having something like this, that this is our IL. So this IL is actually combination of this IP and this IP. So when two currents combine, we get this one. Now we are saying that this is our current. Let's say 5 ampere is the line current. So what will be the phase current? So phase current would be lesser than this line current, because two phase currents are getting from a single line current. So here what will happen, we can say that IP is equal to IL and divided by under root 3. So IP is less than IL. Why it is less? Because the line current is dividing into two parts. But VP is equal to VL, because this voltage and this voltage, line voltage and phase voltage, are same. So in delta connected source, the current is divided by 3. So it is divided by 3 when the line current is converted to phase current. But the voltage in phase and line in delta connection will remain same. So same voltage and reduced current. Okay, if we are having something like this, so here if we check the IL and IP, so IP is equal to IL in Y connected. So current will remain the same in phase and line in Y connected. But what happens to voltage? This is our VL. So this is our VL and this is our VP. So VP is less than VL. Actually the VP is calculated from VL by dividing it by under root 3. So the voltage is divided by under root 3 when the line voltage is converted to phase voltage. So as you have already expected, that we are repeating it in a bit easier way now in this diagram. So we are having, let's say, this thing, and now we are converting from line to phase. So IL, IP and IP. So IP is equal to IL by under root 3 and VL, VP are same. Similarly, if we write something like this, so IL is equal to IP. So IL is equal to IP and this is VP and this is VL. So VL is equal to, is greater than VP and VP is equal to VL divided by 100. So this was the summary of the previous slide. I hope you have gotten it. Okay, so we discussed this thing to calculate the three-phase power actually. So what can we say about the three-phase power? if we want to calculate the phase power of a single phase. So let's say this is a resistor R, and the current that is flowing through this resistor is I, and the voltage across this resistor is V. So the total power S, which is equal to P, will be equal to I square R, or V square by R, or I into V. So if we have, like, let's say three resistances here, and this is I1, I2 and I3. So now the total power will be S is equal to S1 plus S2 plus S3, whereas S1 is equal to I1V, S2 is equal to I2V, S3 is equal to I3V. If I1 is equal to I2 is equal to I3 is equal to I, then S would be equal to IV plus IV plus IV, 3 IV. Now let us consider that this I is actually I phase, the phase current, IP, IP and IP, and this voltage is VP. So we can say that IP, 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 IP and VP, VP would be equal to 3 IP VP. So actually when we combine these three power, S1 plus S2 plus S3, we get the total three phases power. Okay, so this is our general discussion about adding powers of different phases. Now what happens is that if we are having a star connected let's say source, and we want to calculate that how much power is this particular source giving, so we will write IP here and VP here, and we will say SP is equal to IP VP. Similarly this would be again IP VP, and this one would be again IP VP. So the total power would be 3 IP VP. Now what happens is that when we convert the same phase power to line power, we are talking about phase power here. If we want to calculate S line, what will happen, we will check that what's this current on the line. So IL is equal to IP, so we say that here it is same IP, but the V on the line is between these two, there is not this ground, these two, so the V is increased by under root 3, so under root 3 VP. So S line is equal to under root 3 IP VP. We can also write it as S line is equal to IL VL. So single line power would be this thing, IL VL, but we are interested in S line with respect to phase because we are considering phase as the base quantity here. Now the S line in star would be equal to under root 3 IP VP. Okay, if we are considering a delta connected source, this is our VP and this is our IP. So phase power SP phase would be equal to IP VP. Now the voltage VL would be equal to VP, so S line would be equal to VP multiply by, now checking the current here it is 1 IL, but when we go out two currents adds up, so the two currents will make this IP as 3 under root and IP. So S line would be equal to under root 3 IP VP, which is same as this one. So S line and delta is under root 3 IPVP, S line and star is under root 3 IPVP, but we are considering phase as the base quantity. Now what happens if we consider line as the base quantity? What is mean by base quantity? That the data that is given is about phase. So let's have an example on this. Okay, so we are given with, let's say we are talking about the phase as base quantity. So let's say we are having IP is equal to 3 ampere and Vp is equal to 12 volts, and find P line or S line, not P line, S line, total power. We are talking about total power. Okay, else we will use a cos theta with it. So P is equal to S cos theta. We will use a cos theta with it. Okay, but that is not applicable here. Okay, S line would be calculated as what? As phase power. So first, if we calculate the phase power, S phase would be equal to 3 into 12, which is 36 volt ampere. S line would be equal to under root 3 into 36. Similarly, if we want to calculate it using this particular method, so S line would be equal to under root 3 IP Vp, which is again same thing, under root 3 12, which is under root 3 into 36 volt ampere. So this is our S line. So we are given with this quantity. What if we are given that IL is equal to 12 ampere and Vp is equal to 3 volts? So now these two things are different. So for that we will now check that if it is delta or Y. So for that we are using the other condition as well, which is the line as base quantity. So when we are having line as base quantity and we are having three phase Y connected. Okay, so this is our, let's say, Vp, and this is our VL, this is our IL, this is our IP. So now this thing is our base quantity. So IL would be equal to IP in star. So IL would be equal to IP. But the Vp will be now calculated as under root 3 divided by divided by under root 3 of VL would be equal to Vp. So Vp is VL star divided by under root 3. Now the phase power would be calculated as S phase is IP into Vp. So IL into VL by under root 3. Okay, so this is now our first phase. If you want to calculate 3 phase power, so 3 into S phase, 3 into VLIL divided by under root 3, which is under root 3 VLIL. Why? Because this 3 can be written as ILVL by under root 3, which is written as under root 3 into under root 3, this one, and after that ILVL divided by under root 3, which is ILVL into under root 3, this one. Okay, for delta, if we consider delta connected source, VL would be equal to Vp. So Vp and VL are same, but this IL would be reduced to IP as IL divided by under root 3. So phase current would be equal to the line current divided by under root 3. Hence, if we multiply these two, the phase total phase power would be VL IL divided by under root. Remember that In Y, the voltage divides by under root 3. In delta, the current divides by under root 3. But the product of both remains the same. Okay. So from this discussion, we have concluded that the 3 times IPVP is equal to under root 3 ILVL, because sometimes we convert IP as IL divided by under root 3 and write VP is equal to VL, which turns out to be under root 3 ILVL. Sometimes we write IP is equal to IL, but we divide VP as VL divided by under root 3. So when we multiply it, we get same under root 3 ILVL. So in both cases 3 IPVP is equal to ILVL. How? Let me repeat it. Let's say we are having 3 IPVP and we are having delta connection. So in delta, the voltage will be same, but this would be divided by under root 3 for a single phase. So 3 IL divided by under root 3 into VL. If we are having something like this, a star, so here 3 IPVP would be equal to, now this current is not divided, so IP is equal to IL, but VP is now divided, so VL divided by under root 3. So in both cases we get this answer for 3 phase. Okay, the last topic, which is the conversion of load. So in conversion of load, we are having star to delta and delta to star connection. So here are the 3 formulas for calculating from delta to star connected load. Sometimes we are having circuits like this. Let's say calculate the resultant RT, R1, R2, R3, R4, R5. तो RT अगर हम इसमें कैलकुलेट करना चाहें तो what will we do? If we calculate it like this, so it will be hard for us. We will use KCL or KVL. So what if we convert this delta into something like this? So now we are just having this R B, R C, R A, R4, R5. So add RC with R4 and RA with R5 and make these things parallel and then add it with B. So here we are having no solution, and here we are having the solution of RB plus RC plus R4 in parallel with RA plus R5. Think about it. But this is the formula, that if we are having a delta connected load, we are talking about load now. So if we want to convert it to star, what we will do is that we will write A and B in numerator and divided by A plus B plus C in denominator, and that will be equal to the center line P. Similarly, if we want to convert this line, so what will we do? We will write AC divided by A plus B plus C. If you want to convert this line, what will we write? We will write BC divided by A plus B plus C. So this is termed as R, this is termed as Q, and this is termed as P. So PQR. Okay. So what's the shortcut for it? If we are having, let's say, this load and this load, and we want to convert it to this intermediate load. So what will we write? Let's say this is R1, this is R2, and this is R3. So it will be RA is equal to R1 R2 divided by R1 plus R2 plus R3. Similar cases for all the three sides. Here is a problem on it. We are having this delta connected load, and we want to convert it to a star connected load. So we want to convert it to something like this. So if you want to calculate this one, this would be equal to 20 multiplied by 30 divided by 20 plus 30 plus 80. This turns out to be 12.31. Okay, if you want to convert, if you want to calculate this branch, that would be equal to 30 multiplied by 80 divided by 30 plus 20 plus 80. This branch would be equal to 20 into 80 divided by 20 plus 30 plus 80. So this is 1 and this is 3, this is 2. So this can be like R2, this can be like R3, this can be like R1. So R1 is our P. So P is equal to AB divided by A plus B plus C. A is 20 and 30. So 20, 30. So this is our RA, this is our RB, this is our RC. Okay. So we have calculated it like this. Okay. The second one, from delta to star connection, that is easy, because now we want to go from a single line to two lines. So a single line is the single line is written in the denominator. So we will, let's say, if you want to write about this P, so we will write this as okay. So this P is getting two sides here. So for these two sides, we will calculate two values. So this can be like, or between 1 and 2 can be or A, between 1 and 3 can be or B. So we want to calculate this A and B. So for calculating this A, we will write this R opposite resistor in the denominator. So remember that when we are going from star to delta, let me write it on another marker color, and I want to calculate this side, I will write this thing is in the denominator. So denominator would be here as R and combination of all the resistor. So that is like resistor this into this, this into this, this into this. So PQ plus QR plus RP. So similarly for let me use another color. For this side we will have divided by Q and PQ QR RP, and similarly for this side I will have divided by P and PQ QR RP. Okay, so this is the formula. Now let's solve an example on this one. This is the simplified formula that it is cancelling out these terms in it. So let's say if we are having P here, so this P will cancel out with this one and this one, so we get QR by P plus Q plus R. Okay, so this is the simplified version of this, that P is equal to C is equal to QR by P, R and Q. Okay, so here is an example that we want to convert a Y connected load to a delta connected. So how will we connect it? So we want to find this side. So if we want to find this side, what will we do? We will divide it by 180 and then we will write 150 into 180 plus 180 into 60 plus 60 into 150. So this line will be calculated like this. Similarly, this line will be calculated as divided by 60 and 150 into 180 plus 180 into 60 plus 60 into 150. So this is this line. Similarly, this line would be calculated as 150 in denominator and 150 into 80 plus 80 into 60 plus 60 into 150. So we get these three values, 780 ohm, 260 ohm and 312 ohm respectively. So this is how we convert a Y to a delta when it is load. Okay, I guess this is enough for today, and let's see if we have any problem, and we will discuss it in the interactive session. Thank you. Thanks a lot.